Hi, this is Chuck Benedict, mentor for Team 997 Spartan Robotics, back with a final, I keep saying final, it's final video on my series to talk about building a device driver for a color sensor. This is actually not the last video in the series. It's a correction video because my lead technical mentor at our club looked at my videos and overall gave glowing reviews, except he's an electrical engineer by trade, and he thought my electrical discussion on one of the earlier videos was pretty poor. Okay, he didn't really use those terms. He just said you might think about it a little more. After I went back and looked at the video, I realized that it was basically trash and just didn't do the topic justice. Now, I'm not an electrical engineer by trade. I'm a hobbyist. I think I know a reasonable amount, but actually he is an electrical engineer. And so I thought I would come back and talk a little bit in some greater detail about the electrical discussion. It may be more than you need to know, but it'll be certainly a more complete and more accurate discussion. So here we go. Let's get into it. The big thing that I failed to mention when I talked about connecting the sensor to the roboRio is that the sensor itself, so let's go back to the data sheet of the sensor. First thing I did when I went in here to talk about electrical characteristics is I went to the absolute maximum section. This is the data sheet for the color sensor, by the way, the TSC34725. I went down to the electrical characteristics, and in particular, I went down to the absolute maximum, and I looked at 3.8, and I said, oh, okay, it's a 3.3 device. And technically that's correct, but really what you should do is you should go down and look for the supply. Again, I have a TCS 34725 because that's what the thing has on it. That's the number that the device has on it. But the nominal operating voltage is 3 volts, minimum is 2.7, max is 3.6. So, this tells you the device that the voltage that you're supposed to operate the device at. So there's one correction. Second correction, this is the chip that is on the breakout board. You don't directly connect with the chip. The breakout board is actually what gives you the pinouts, and there can be circuitry in between the chip and the pinouts, and in fact there are. And I basically totally blew off the work that the Adafruit engineers did in my discussion. And in particular, again, read the documentation. We add support. This is on the Adafruit site on the actual breakout board. We add supporting circuitry as well, such as a 3.3 regulator, so you can power the breakout with 3 to 5 volts safely, and level shifting for the I2C pins so they can be used with 3.3 and 5 volt logic. Thank you, Adafruit. They're basically making it idiot-proof so you can plug almost anything into it and it won't blow the chip up, which is very nice of them. I had further questions when I read that. I don't know. I didn't believe them. I don't know. I'm just curious. I'm a curious sort. So, after I get called out on doing things incorrectly, I actually want to dive down into the details so that the next time I do something like this, I just know more what I'm talking about. So I went and looked at the schematic because I was curious how they did it. This is the Adafruit schematic of the sensor, and just a couple of things I wanted to note here. This is the voltage regulator. So when you see VN, which is what I wired the thing up to, what's VN actually going into? It's going into this low dropout regulator, and you'll notice that you put voltage in, you get 3.3 volts out. So I started thinking to myself, well, I know the roboRio on the I2C port puts out 3.3 volts. So what if VN and Vout are really, really close together? What happens to this voltage regulator? Well, it is a low dropout regulator, and so it's designed to operate in those conditions. And I've confirmed that the thing works fine plugging it into the roboRio, so the dropout must be really low. Remember that the sensor can operate at voltages all the way down to 2.7 volts. and maybe an electrical engineer can help me understand what happens when it gets really close, because let's go to the data sheet on, this is the regulator that's connected on the board, Rich Tech RT9193. At least that's what this says right here. So the dropout voltage, which is defined as the difference between voltage in and voltage out on this particular chip, is when you're drawing 200 milliamps and the output voltage is greater than 2.8 volts. The typical dropout voltage is 170 millivolts. So, what I'm, and I haven't measured these voltages like to see what the actual output voltage from the roboRio is, but if you're starting to, if it's 3.3 volts and 3.2 volts and you're kind of within that dropout, does the chip actually drop out and stop? Does it just go out of regulation, or does it completely cut off the voltage? I don't know all these details. Maybe an electrical engineer that watches this video can kind of help me out and help me understand this a little better. All I can tell you is that when I plug the thing into the roboRio, it works. But in any case, these are the things that you Sparkies, go concern yourselves with. And so maybe somebody watching this can help me out. In any case, that's okay. These are level sensors. These three devices here are not level shifters. And so what that means then is when you put anything between 3 and 5 volts into these things, you'll wind up getting 3.3 volts out. And so, you can see here SDA and SCL, that's the data line and the clock line. These are the actual inputs from the breakout board. You can see them labeled over here. So that's what we're actually connecting to. So when you connect those to the roboRio, these are basically inputs from the roboRio. They come through these level shifters and they go out to the color sensor SDA, SCLs, because this thing is not 5 volt tolerant. You can only put 3 volts, I guess it's 3 volts into this thing. So that's why these things are sitting out here on the breakout board. And actually, let's go look at the roboRio data sheet, because it would be incomplete without looking at it. You can see on page 10 of the roboRio data sheet, I2C lines with 3.3 volts output, 3.3 volts to 5 volt compatible input. So you can actually drive the inputs on it up to 5 volts. So the roboRio is actually quite tolerant. So there you go. Finally, I wouldn't be incomplete electrical discussion without noting these other pins. So there is an INT pin and an LED EN pin. The INT pin, I didn't discuss this in the driver discussion very much. There is an interrupt function on this color sensor which allows you to set thresholds of clear light measurement, through which you can cause the chip to assert this pin, which if you connect this pin up to a digital input on the roboRio, you can actually cause your code to take action when that pin asserts, which saves you from having to poll the device all the time to say, hey, give me your color, so give me your color. I don't take advantage of it, and in fact, I don't even connect the breakout board. Actually, I don't have it anymore. I keep looking for it. I don't have it. I gave it back. It keeps you from having to connect, and I don't connect the interrupt pin to the roboRio at all. And so if you try to use that feature in the driver, it's not gonna work. At least I don't think so. And now I'm hard pressed to remember if there's code in there to do it. In any case, I didn't test it. I don't know if it works. So hey, if you try it, use it at your own risk. And the way the polling mechanism works in the sendable base method, it polls all the time anyway. So putting the interrupt code in there, it doesn't seem to me like it's all that useful, but you know, use at your own risk. Finally, the LED in, that's LED enable. If you look at the little circuit here, it looks to me like LED in is pulled up to 3.3 volts. And indeed, when you power the device, the LED comes on automatically. I have nothing connected to LED in. When I did my tests, again, you could connect this to a digital output on the roboRio and manually twiddle the state of the LED if you wanted to yourself. You'd probably have to pull it down because it looks like it's permanently pulled up. So you'd have to supply ground to it in order to turn the LED off. And again, my driver logic does not take any of that into account. So you'd have to add some methods if you wanted to do that. And you're certainly free to, and I encourage people to fork my code and do that. And if you want, send me a pull request, and I will incorporate that into my code. So that is probably a whole lot more than you non-Sparkies care to know, but I at least want to do the subject justice. And again, lesson: read all the data sheets. Don't if you really want to A, understand why your device is not working correctly if it's not, or B, if you blow it up and you see and you let the magic smoke out, it's because you didn't read the data sheets. Go read the data sheets, and if you don't understand them, go grab a mentor that knows something about electronics and ask them. They'll be glad to help you. Thanks for watching.